Right, next we'll work with set number 2, question number 3. An actuary studying the insurance preference of automobile owner makes the following conclusions. First conclusion is that automobile owner is twice as likely to purchase collision coverage as disability coverage. So now I start, hopefully you get used to this kind of language. It's twice as likely, so its probability of getting collision is going to be 2 times the probability getting a disability. Then the event that an automobile owner purchase collision coverage is independent of the event he or she purchase disability coverage. Now, this is actually a section talk about conditional probability and independence. Independence, it does not mean they cannot happen at the same time. All right, I want you to be clear with 2 concepts. Mutually exclusive and independent are 2 different concepts. Independent means like they just doesn't interfere with each other. It's like whether you go to Gauss class or not, and whether I don't know, you like a Starbucks or Dunkin' are independent events, but it could happen at the same time. Like you bought a Starbucks, then you still go to Gauss class. However, there are also things are mutually exclusive, which in the case maybe you're only gonna buy one coffee, you're either gonna buy Starbucks or Dunkin'. That may be mutually exclusive. It will not happen at the same time. Or it's something like a queen or the king mattresses. You're only gonna buy one. Those are mutually exclusive. So in this case, they still can happen. It's just the way they calculate they're happening at the same time have a different way to process them. So in this case, it's saying collision and disability. Number 2, collision, disability, they are independent. It does have a consequence. It does have an indication when they say they're independent, because that means the probability of C and D at the same time is equal to probability of C times the probability of D. I'm starting using abbreviation, so like I'm using C in this case is actually really probability of C equal to 2 times the probability of D. I'm just using the letter C and D to represent probability. Now I'll talk about the third one. The third one says the probability and that an automobile owner purchased both is 0.15. So it's literally saying probability C and D, which is purchase both, 0.15. And what is the probability automobile owner purchase neither collision? And asking you question is probability neither C or D. That's what they're asking. You can still use a Venn diagram for this question because C and D could happen at the same time. So you'll have C and D in this case. You will have 0.15 here. That's 0.15. It's asking you the very outside. And you also know they are independent. The P of C and P of D are related. So what I'm going to do is probability, or I'm going to start using some abbreviation, which is C times D is equal to 0.15. And C equal to 2 times D. I actually could calculate D in this case, right? Because I can plug that in. So C times, so 2D times D equal to 0.15. All I'm trying to do is plug in 2D for C. Then I got 2D times D. And in this case, you will get D squared equal to 0.075. You can find out what D is. Once you actually got D, you're actually also able to get a C, what C is. Right? Let me do the math real quick and take a square root of